Welcome to this video on solving systems of equations using elimination. By the end of this video, you should be able to eliminate a variable and plug in your equation into the other equation and solve for the given variable. And we call that elimination. You should also be able to decide which method of solving a system is best based on how the equations are set up. So let's talk about elimination. So the elimination method is a method of solving systems of equations by eliminating one of the variables using addition, subtraction, or multiplications to create matching opposite coefficients. So you want to eliminate or get rid of one of the variables. That's your goal. To solve this is best when x and y are on the same side of the equal sign. That's standard form. When we write our equations, we have to be sure that the x and y variables are lined up over each other. And so you will be looking to have opposites so that the variable will be eliminated and then solve for the remaining variable. Once you have that remaining variable, you're going to substitute it into one of the original equations and solve for the other variable because we have two different variables that we have to solve for. All right, so let's take a look and see what we can make happen here. We have our x's and our y's lined up over each other. We are looking for ways to make opposites so a variable can cancel out. There's usually a couple ways that you can do this. I see that I have x's and they're the same coefficient with a 1 in front. I could multiply the bottom equation or the top equation, it really doesn't matter, but only one of them by -1 to create a negative x, which would be opposite. I could multiply the bottom equation by a 4, which would make this -4y, which would cancel out with the positive 4y. There's a couple different ways. So I think I want to show you, let's take this top equation. Now notice I'm going to multiply the entire equation. I'm going to multiply it by -1. Okay, so what I get is I get negative x minus, because I'm distributing, -1 times positive 4y is -4y. Then I have -1 times 13 equals -13. So I'm going to ignore this one up here because I rewrote it down here. So I have x minus x. Well, those guys canceled. They eliminated. That's the whole purpose of what we're doing here. Now I'm left with only y's. I have -1y minus 4 more y's, so I have -5y equals 3 minus 13 is -10. Okay, so we're going to keep solving for y because we eliminated the x. Divide both sides by -5 and I get y equals 2. So that tells the y value in our solution, because remember, your solution is always a point. So if you know the y value, we know that part of it. We still need to find out the x value. So what I need to do is take this y value 2 and I need to plug it into either one of these equations, and it really doesn't matter which one you pick. I'm going to pick the first one. It says x plus 4 times y, well y is 2, equals 13. So we get x plus 8 equals 13, and then solve for the x. So I get x equals 5. If you were to graph these two, put them in slope-intercept form and graph them, they're going to cross at 5, 2. If we tried substitution, you would get 5, 2. If we try elimination, you'll get 5, 2. If we had picked a different way to solve this, we still would have gotten 5, 2. The solution is the solution, and there's a bunch of different ways we can get there. All right, let's try looking at number 2. So remember, you're always looking for opposites so something can cancel out. So when I look, I've got x and y lined up over each other, and I just happen to have 4x and a -4x. I already have opposites. I don't have to do anything, but we're going to add them or follow the signs going straight down. So I have 4x minus 4x. They cancel. They eliminated. That's the whole purpose of what we're doing. You want one of the variables to go away. Here I have 9 plus 7. That is 16y. Equals 5 plus 11 is 16. Divide both sides by 16. And you get y equals 1. So I know in my coordinate point, I know the y value. I need to pick one of these two equations to plug into for what I already know to solve for the x. I'm going to choose the top one. It did not matter. So I have 4x plus 9 times y, well y is 1, equals 5. So we get 4x plus 9 equals 5, and just start solving. Subtract 9 from both sides. 4x equals negative 4. Divide by 4 on both sides, and x equals negative 1. So if we were to graph these, put them in slope-intercept form and graph them, they would cross at negative 1, 1. If we were to use elimination or substitution, we would get the answer of negative 1, 1. Elimination, if we had chosen a different route to go, our answer is still negative 1, 1. All right. Let's keep trying and see how we do. X and Y is lined up over each other. I need to make opposites. So the one I see right away, since this is just an X, and this is a positive 2X, if I multiply the X by negative 2, I'd have negative 2X and positive 2X. Those will cancel. That's one way to do this. So I'm going to multiply the whole top equation by negative 2. You're not changing the value, you're just making an equivalent equation. Okay, so you have negative 2 times x gives you negative 2x. Negative 2 times 3y is negative 6y. And then you have negative 2 times 6 is negative 12. Okay. Now, adding straight down, you got 2 minus 2x, they eliminate, they're gone. Then I have negative 7y minus 6 more y is negative 13y. And I have negative 1 minus 12, which is negative 13. To get y alone, divide by negative 13 each side, and you get y equals 1. So now I'm going to pick one of my original equations, and I'm going to plug 1 into it. I'm going to pick the top one because it's going to be easy to solve for x there. So we got x plus 3y, well y is 1, equals 6. So x plus 3 equals 6. Use your inverse operations, and x equals 3. So we're going to write our final point, 3, 1. All right. Let's turn this over and try some on the back. All right, looking at number 4. We've got our x's and our y's lined up just like we're supposed to, and I'm trying to make an opposite. I could make this, I could multiply the top by 5 and the bottom by 3 to make these both 15. One of them would have to be negative, so they'd be opposite. But I also see I got whenever I see a single variable like this, I like to look, what could I multiply that to get it be opposite this? This is negative 1y, that's positive 4y. If I multiply this by a 4, I'd get negative 4y, which is opposite. So that's what I usually look for. I'm trying to go for the simplest way. So I'm going to distribute the 4 through the entire equation. So I have 4 times 3x gives me 12x. Then I have 4 times negative y gives me negative 4y. And then I have 4 times 14, break out the calculator, and I'll get 56. Okay. So now, kind of ignore this top one because we just rewrote it here. Let's add, going straight down, 5x plus 12x, 17x. Positive 4y minus 4y, they eliminate, which is what we wanted to have happen, equals 12 plus 56 is 68. So now we're going to divide, and x equals, well, what's 68 divided by 17? And that is 4. All right, so now we have an x value. I want to pick one of these equations to plug in the 4 for x to solve for y. It doesn't matter. I've used the top one several times, so let's use the second equation here. So we have 5 times x, well remember x is 4, plus 4y equals 12. So 5 times 4, 20 plus 4y. And then we're going to solve just like always. Use our inverse operations. So we get 4y equals negative 8. Divide by 4 in each, and we get y equals negative 2. So I have an x value and a y value. Make sure you put them in their correct spot. And that's the name of the point where they cross. All right, I want to do one more with you and we'll finish the rest in class. Let's see what happens. So here, I have x over x, y over y, so we're set up there. I need to make opposites. These are both positive 3x's. What if I multiplied one of them by a negative 1 to make it a negative 3x so it will cancel? Let's try that. So if I multiply that by negative 1, let's distribute this through. So I get negative 3x. We have negative 1 times 4y is plus 4y. Then we have negative 1 times 10 equals plus 10. Okay, so let's look at it. We rewrote it 3x minus 3x, that eliminates. Then I have negative 4y plus 4y. What? That also eliminated. There is nothing left on that side, so everything canceled to 0 on that side. But over here I have negative 13 plus 10. Does 0 equal negative 3? It does not. A 0 can't equal negative 3. So what do you think that solution might be? A number can't equal another number. So we're going to call that no solution. So that's one of our unusual cases. So that means these lines are parallel. They'll never cross. So if you get a number equals a different number, that's going to be no solution. I wonder what it would mean if you get a number equals the same number. What would that be called, do you think? We'll find out. We'll finish this out in class. See you then.